Hi, and welcome to Always Eclectic Stacy. This is 5 Minute Chemistry, where you learn chemistry concepts and see examples in 5 minutes or less. Today we're talking about different ways of modeling covalent compounds, and this is carbon dioxide. Let's get modeling. Today we're going to be modeling CO2 in 3 different ways. The first way we're going to talk about is a traditional Lewis structure. So with carbon, remember carbon has 4 valence electrons, and each oxygen has 6 valence electrons. And that's each oxygen. If you're doing this with me, just remember to draw each one out so you can see each one. Now, you always put the one with the most bonding potential. That means most single dots in the center. So carbon's going to go in the center. And you're going to go ahead and put on either side an oxygen. It really helps if you put in your bonding pairs first. So you got 2 here and 2 here. And because we put carbon in the middle, we cannot put the bonding pairs in the middle. So we're going to put 2 on top of each, and that's just traditional. And then you ask yourselves, each oxygen needs 8. So we have 2, 4 right here, 2, 4 right here, and we have each one with 1 bonding potential, which means each oxygen needs 2 bonds, and carbon needs 1, 2, 3, 4 bonds. So because each oxygen needs 2 and each carbon needs 4, 4 divided by 2 is 2, so carbon can double bond with each oxygen, and that fulfills its bond. So remember, each line is 2, so it's 2, 4, 6, 8. This oxygen is happy. 2, 4, 6, 8. This carbon is happy. 2, 4, 6, 8. This oxygen is happy. Now, another way of doing that is using your Lewis dots to show how the electrons share. So you can go ahead and put carbon again in the middle. And then you're going to go ahead and put oxygen on either side. Don't forget to put in your bonded pairs. And then what you're going to do is go ahead and do 1 dot on either side for carbon to show the 2 that it's going to share. Then you're going to put 1 dot on either side for the oxygen that it's going to share. And I didn't make them quite even, but that's okay. And then you could kind of do this line here, showing that it is an orbital that is being shared and showing who is sharing by each of the electrons if you have a hard time following just the dots. It's a different way of modeling that Lewis structure, but this is the most accurate. But if you want to show where all of the electrons are being shared, this is another way. Next, we're going to go ahead and use Bohr models to model it. And if you just give me a second, I'll draw them and I'll pop right back on the screen. Okay, now we're going to model using Bohr models. Now remember, for a Bohr model, you have your nucleus, you have that first ring, which is your s orbital, which holds 2, and then your second ring, which will hold 8. For carbon and oxygen, we don't need more than that. So I've already started by putting in what the element is. So it's oxygen on the outer 2 and carbon in the middle, just like we did up there. And with each oxygen, we're going to go ahead and put in these 4 electrons in this outer ring because they are bonded pairs. They aren't going to be shared at all. We're not putting in anything for carbon right now because we know that with 4, they need to bond at least 4 times. And you can see here, I didn't do it as well over here, that I have this overlapping orbital. And what we do is we go ahead and we put in this overlapping orbital the shared electrons because they make a bond in this overlapping orbital that gets shared. So 1, 2, 3, 4. We're going to do the same thing over here. We're going to pretend that this is a little bigger. So 1, 2, 3, 4. And then an easy way is just counting the electrons in your outer ring. So you have 1, 2, 3, 4, 5, 6, 7, 8. That all counts as that outer ring because it's an overlapping outer orbital. And yes, now oxygen has 8 in its outer ring. 1, 2, 3, 4, 5, 6, 7, 8. This oxygen has 8 in its outer ring, and each carbon has 1, 2, 3, 4. 1, 2, 3, 4. 4 plus 4 is 8 in that shared orbital. And now carbon has 8 in its outer ring. So you can see through these 3 different methods, Lewis structure, electron dot, and Bohr model, that you can prove that there is a full electron orbital in each of the outer rings, which is what the goal of Lewis structures and modeling and bonding for covalent bonds. Thank you so much for watching. Always eclectic Stacy. If you like what you see, please check out my other videos, and please do not forget to like and subscribe. Have a great day.